Hello and welcome back to the channel. It's beautiful to have you here as we continue to discuss science. Today we are discussing batch culture. What's a batch culture? Now, this is the most common way by which we prepare culture media and then grow microorganisms in the lab. The use of batch culture. And what's a batch culture? A batch culture is a closed system. It's a system where we're able to grow microorganisms within either a petri dish or using broth, liquid broth. And in this system, we have no external interference. We build the system up in such a way that we have our media, we inoculate it with our microorganism, and then we allow it to grow without removing any waste of the microorganism and without adding extra media or nutrient to the system. So we see that the system is a closed system. It's a closed culture, it's a batch culture. So the microorganisms grow within the culture and then we study them over a period of time. And when it is up, we just continue to study them like that. Now, within a batch culture, it's important to note that we do not add extra nutrients. We allow it to just grow as it is growing. Now, how do we prepare a batch culture? What are the processes that we use to prepare a batch culture? First of all, we prepare our media. So we know whatever media it is that we want to use, whether it's nutrient agar, McConkey, EMB, whatever media it is that we want to use, we prepare it. And how do we prepare the media? We have measurements, we have manufacturer's instruction. So we measure according to manufacturer's instruction for the amount for which we want to prepare. And then when we've measured, we sterilize, we fill with distilled water to a particular level. Most of the time it's 500 ml, and then cork very tightly and then sterilize. We sterilize the media for a period of time. And when we've sterilized this media, we usually sterilize it in, depending, you could use a water bath, you could use a heater. When we have sterilized for a period of time and we're sure that, the idea is to make sure that there are no microorganisms in the water that is going to grow and even in the media. And when this has been done, we allow it to cool and then we pour into petri dishes. Then, depending, if it is broth, we know that we are not pouring into petri dishes. We're going to just inoculate our organisms into the broth. After the media has been prepared, then the organisms from whatever, sorry, not the organisms, the samples from whatever sample it is we are taking, whether it is water sample, soil sample, fecal sample, whatever it is, we then inoculate our media through many of the methods, either streaking, pour plate, spread plate, whatever method it is we are using, we're going to inoculate our media and then we allow to grow. We incubate. And when we incubate in an incubator. We set the right conditions for pH, temperature, pressure, and then depend over a period of time, many times perhaps 12 hours, 24 hours, 48 hours, we continue to observe. Now we try to observe microbial growth. And microbial growth, we try to observe it. There are quite a number of ways. You can look at optical density, look at turbidity, or simply look at viable growth of microorganisms, growth of cultures, viable cultures. So you just with your naked eye look at your media, examine your media closely. You could see that different colonies of the microorganisms begin to grow. You could count these colonies using a colony counter, and then you have the growth of these microorganisms. So this is what we have in a batch culture, and it's what we do in the hospitals, in the research labs, for agriculture, very different places. We continue to use this method, the method of batch culture, which is a closed system where the microorganisms are grown and there's no extra input of nutrients into the system and there's no removal of the metabolites or the toxic waste of the microorganisms. So that is what we have in a batch culture. Now, it's important to note here that the batch culture follows the popular microbial growth curve. It follows the popular microbial growth curve, and that microbial growth curve can be studied using the batch culture. So you have the lag phase, which is the phase when the organisms are just getting to be metabolically active. They are acclimatizing to the environment of the media, and that's the lag phase. And so the growth is slow. And then from the lag phase, we move to the log phase, which is the exponential phase where the microorganisms have acclimatized to that media and they grow very rapidly. There's rapid turnaround time. The microorganisms are growing really fast. And you can see that on the microbial growth curve when it's drawn. And then you move to the stationary phase where microorganisms are not growing as fast as they were growing before. Some of them are beginning to die, and then it reaches a stage where there is net growth. So the number of microorganisms that are growing and the ones that are dying are equal, and so the line, becomes a straight line because there's no net increase in growth of microorganisms. And after a while, we begin to see a decline because at this point, most of the nutrients in the system has been used up. And remember that being a batch culture, the nutrients are not replenished. So you begin to see the tapering down of the curve. And then from there, you see the breaking of the curve and it all tapers away. So that's what we have in the microbial growth curve, which the batch culture follows. And it's important to note that the batch culture is a closed system. It has finite growth, conditions can be varied, and it follows a predictable growth curve. And like I said, it is used in research, it's used in the hospital, it's used in agriculture, it's used in industry, it's used in teaching. So this is really, really important. It helps us to understand microbial growth. It helps us to understand how microorganisms, react. The advantage is that it's a simple method, it's easy to use, it's relatively inexpensive, and these are some of the advantages. The limitations is that conditions usually change over time, no matter how hard you say you try to keep it constant. And so, really, what you're watching is not a system where the conditions are going to be permanent over a long period of time. And it's not a suitable method for continuous production of a microorganism or continuous production of the metabolites of a microorganism, as you like to see in some industrial processes. So this brings us to the end of this video. I hope we've had a wonderful time discussing batch cultures. You can go through the video once again and drop your comments or questions in the comment section. Remember to like us, share, enjoy our content, and have a beautiful day.